Hello students, the most important part of atomic structure, that is the electronic configurations. Why? Because the properties of the elements, the formation of compounds depends upon the electronic configurations. So how that arised? That arised from the quantum concepts and quantum numbers. Quantum numbers explains the position, motions, the state of electron in the orbital of atoms. So from that we derived a diagram, that is orbitals, their numbers, and what will be their positions using circular representation. If we represent the shells as represented in diagram, 1 2 3 4 5 shells if present in the atom, means from principal energy level n is equal to 1 to 5. If shells are K, L, M, N, O, from chronicle symbol K to continuous L, M, N, O. In this way, we represent the circles according to quantum numbers for principal quantum number. That circles derived from the orbital quantum numbers L and have the values as M, magnetic quantum number, and electrons will have the spin quantum number, spins clockwise or anti-clockwise, plus half and minus half. If we represent the lines for the orbitals, inclined lines joining, so in this way we can derive the electronic configuration sequence of orbitals for their energies by joining lines like this: heads and tails of successive lines, inclined lines joined to the orbitals. On the line we have to move and we will get the correct sequence of the orbitals in the electronic configurations of atoms for periodic table for 4 blocks, S, P, D, F block elements. Total 117 elements are there, 92 natural, other synthetic elements in the block S, P, D, F. So the orbitals can be represented as a 1s, 2s, 2p for the circles, 3s, 3p, 3d, 4s, 4p, 4d, 4f in the energy level fifth as 5s, 5p, 5d, 5f. Next successive for 6s continuously. So as we move from the 1s, 2s to 2p, then 3s, 3p, 4s. 4s is filled first, after that 3d. That is obtained from this diagram, inclined joining head to tail. 3d, after that 3d, the 4p is present, 5s, 5p, 4d. In this way we get the electronic configuration sequence based on the quantum approach, or quantum science explains the correct sequence of orbitals for their energy. What is that sequence? 1s, 2s, 2p, 3s, 3p, 4s filled first, then 3d, 4p successively orbitals as inclined joined lines of the orbitals. In this way we get the correct sequence of the energy levels of the atomic orbitals in the shells. And how we obtained the number of electrons present in the orbitals, that can be obtained from the quantum numbers. Yes, orbital have only one orientation according to quantum numbers, so it occupies only 2 electrons, one clockwise and another anti-clockwise. P orbitals have 3 orientations, px, py, pz, so it can occupy 2 electrons with clockwise anti-clockwise spins, means total 6 electrons can be occupied in p orbital. D orbitals have the type dxy, dyz, dxz. 5 types are there: dx2y2, dz2. 5 orientations according to magnetic quantum number. It has 5 orientation. P orbital have 3 orientation. S orbital have 0 orientation. That numbers obtained from magnetic and orbital quantum number. So in this way, these orientations are there. Each d orbital consists 2 electrons, total 5 means 10 electron capacity of d orbital. In this way, up orbital have cubical shapes, total 7 types are there, and it should have the capacity of into 2 14 electrons. So this number of electrons have to be filled for the energy sequence of orbitals for the elements from s, p, d and f block, and we get the configurations of metals and non-metals in periodic table. Starting with hydrogen, H11 have the 1 electron, 1s, 1a configuration. Helium 2, atomic number 2, mass number 4, have the configuration 1s2. Next element is lithium 3, 1s2, 2s1 configuration, 2s orbital with 1 electron. Next element beryllium 4, 1s2, 2s2. Boron 5 atomic number from p block. It should have the configuration 1s2, 2s2, 2p1. Last electron in the p orbital, so it from the p block. In this way, we can obtain the configurations, the number of electrons filled in the orbitals for the atoms in the periodic table using the basic concepts of the quantum science. So, total 117 elements have the various blocks, positions and various configurations. The valence electrons are important for their atomic properties. So next point we will study what are the stable and unstable configurations. Two types are there for the configurations, stable and unstable configurations. Stable configurations are generally occupied with all capacities of the orbitals. Unstable configurations are with unfilled capacities of the orbitals. Unfilled capacities for the atomic orbitals. So stable configuration means, for example, 6 electrons are there. If 6 electrons are there, then that in that atom configuration would be 1s2, 2s2, 2p, 2 electrons. Means it's a stable configuration. Each orbital have the occupied states of the electrons. What is the unstable configuration? Or atomic number 5, 1s2, 2s2, 2p1. Means one electron is a free here. It can be paired. This atom will not be stable. So if you study the stable and unstable configurations, lots of examples are there in periodic table. For example, if we study the configuration of atom copper, copper has atomic number 29 from D block. It is present in 3D row. It is 3D element, transition element from D block. Copper has atomic number 29. What will be the configuration? 1s2, 2s2, 2p, 6, 10 electrons are filled up to this. 3s2 filled. Then 3p, 6. How many electrons now filled? 10 plus 8, 18 electrons. Then the 4d orbital is 4s orbital is filled first, after that 3d orbital. So here we have to fill the electrons first